right, stat students, this is really for AP stat students. We're continuing some of the content here, prepping for this AP exam. So today, last lessons have been over comparing two populations for proportions. So we got that out of the way. Today we're talking about means. We're going to be making a confidence interval and also running a significance test. Get into it. Oh, forgot the intro. Oh well, we'll just go ahead and get into it. So we're going to be comparing two means. The last video was over comparing two proportions. So we're comparing two means. We're going to be determining the conditions, which are going to be the same conditions we've been meeting for quite some time now. We're going to start by constructing a confidence interval to compare two means, and then we're going to be performing a significance test, and also we're going to determine when it is appropriate to use two sample t procedures versus paired t procedures. So we're going to talk about those as well. You will want to have your calculator handy, so I've got mine ready to go. You'll also want to have your formula sheet handy as well, because we're going to be using this sheet here. These are the formulas that we actually need right there. Okay. So let's go ahead and talk about an example of what we're looking at. Let me pull up this. Okay, so this is confidence intervals for the difference of means. I'll be uploading this sheet to Kitim. Our goal is to construct and interpret a two-sample t-interval for the difference of means. So the example is plastic grocery bags, and a lot of the work has been done on here. But let's just read through it. So it says, do plastic bags from Target or plastic bags from Walmart hold more weight? A group of AP Stat students decided to investigate the filling by filling a random sample of 5 bags from each store with common grocery items until they ripped. Then they weighed the contents of each item in the bag to determine its capacity. Here are the results. Okay, it says to construct a 99% confidence interval for the difference in mean capacity of the plastic grocery bags from Target or Walmart. So the statement has already been made. Now, normally on AP test free response, you would want to write this out, and you'd have to write it out on your own. So we're trying to see the mean difference. Okay, what we're trying to figure out, we want to make this interval for the mean difference of the capacity. Okay. So they have notations here for these means where we're seeing T and W. T is Target, W is Walmart. And so that's what we want to do. We want to estimate that difference at the 99% confidence level, where U of T is the mean capacity of bags from Target in grams, and then U of W is the mean capacity of plastic bags from Walmart in grams. So the plan, if the conditions are met, we will calculate a two-sample t interval. So why is this a t interval? Well, remember that t was always t versus z when we were constructing these intervals always depended on whether or not we knew sigma. So that means that changes what table we're actually using. So we will end up using this t distribution table for this. Okay. Let's talk about the conditions. Are the conditions met? Here is the slide that we're going to be using. So for us to run either the significance test or the confidence interval, we have to make sure it's random. It has to be 10%, both of the samples, right? Less than 10% independent, and they have to be normal large sample. So are they greater than 30, or are they stated normal? So we've been dealing with those same conditions throughout this whole, really the last part of this class. So we're very used to those. Other than that, if you don't know, if either population has an unknown shape and the corresponding sample size is less than 30, so this is very important for what we need, use a graph of the sample data to assess the normality of the population, of the distribution. Okay? If it shows strong skewness, do not use it. So that's what it's saying. So we are we're on this one now. So let's see what they say. We already have this in here. So it is random. I think it says at random sample, but it's only 5 bags. Independent, yeah, it's reasonable to assume that there's more than 50 plastic grocery bags. Sure, but let's talk about normal. Since the sample sizes are small, we must graph the data to see if it's reasonable to assume the population is approximately normal. Since there's no obvious skewness, which, you know, this example is kind of strange just because, you know, we can't, there's not really enough data to put points on there. but this is what you would want to do, is discuss the graph. So they're saying there's no obvious skewness. I guess you'd be looking for points that are far away from their overall distributions here. I guess this meets that requirement. So those are the conditions to be able to create this distribution, or excuse me, these confidence intervals. So that's the next part. We're ready to create the confidence interval for the difference in the mean. So confidence interval, it's still going to follow the same exact formula that it always has. Statistic plus or minus critical value times standard error of the statistic. So critical value, that's going to be based off of the confidence level. So that's 99%, right? Statistic is going to be the difference between these. So we also have, let's pull up our formula here, U2 minus U1. That's going to be our statistic that we're going to want to use there. So in order for us to do this, really we're using this formula here. I mean, I guess we have this. We're subtracting the sample means is what we're doing. All right, so we don't have the sample means, but I've listed out what we need to find. We need to find the sample mean of the Target bags and its standard deviation, the sample mean of the Walmart bags and their standard deviation. So we need our calculator. If you can go ahead and grab yours. And we are going to type in this data and calculate their mean and standard deviation. So I'm going to open up a new document, spreadsheet. We'll call this Target and Walmart. Okay. And we're just going to go ahead and type all this data in. So I'm going to go ahead and skip ahead to where I've done that. If you need to pause, you can, well, I'll type it in with you live here. Seven, 6. Okay, so there's the Targets, Walmart's. Okay, so we got all the data typed in. I actually see that I made a mistake here. This is 13999. That would have thrown things off pretty badly. Okay, so I'm gonna show you a new sort of trick on this calculator, because we can calculate all these statistics at the same time. If you go over to a new cell, normally what we've done is menu 411, right? Now, I've always said hit enter at this step, but when it asks you for the number of lists, we've always just had 1. Now we have 2 lists. So if you press 2, hit OK, it's going to ask you what list you want. Well, let's make Target our first list. Walmart is our second list, and it's just going to calculate them all. We could do a ton of lists here and just calculate all the statistics immediately, which is pretty nice. Hit OK. All right, here we go. We get our value, and that's what we want to type over here. So I'm going to go ahead and type all that in. You're writing it down after these equal signs. We also need the standard deviations, and we need the means. And we're going to round to the standard deviations to 1 place, by the way. Standard deviations to 1 place on here. So I'm going to go ahead and pause and skip ahead to where I've typed all that in. Okay, so I've got mine in now. So those are the mean. These are the means here. We need these to create our statistic. This is the first part. So we take that Target mean minus the Walmart mean. That's going to be our statistic. Okay. Now we have the. Let me insert a symbol here. We need the plus or minus. Does that exist? Plus or minus? Maybe not. I'm just going to put plus, minus. So we're adding, subtracting. So let's go back to our formula here. Next thing we need, so we found our statistic. That's when we're subtracting this to find the difference. Now we need our critical value, and we know that that comes from that confidence level, which in the question, come on, pull up. Where's that? Right here. In the question, it says 99%. So to get that critical value, that's what we need. We go to our T table, because this is a T distribution. And at 99% confidence, we're here, okay? And then what's our degrees of freedom? Well, our degrees of freedom, because we have to have that on this left side, degrees of freedom is, we'll put that, degrees of freedom equals 5 minus 1, which is 4. So what we're looking for, we're going to the fourth row here, 99%. So that is 4.604. Double check that. Yeah, that's our critical value. So that's a very large critical value as well. So the critical value goes here. So that's 4.604. So we're adding, subtracting. Now we have to, let's go to the last part of this, which is we need the standard error of the statistic. So we are using this formula right here. That's the formula we need. So the standard deviation of the first one squared over the N1, or the sample size, plus standard deviation of the second one squared over the sample size. So that's going to be that formula. That's actually in this PowerPoint here. This is how we're creating this interval value. This is a whole formula here. But this is how we find this test statistic, which is what we're referencing. So this is our overall, actually that's for significance tests. We don't actually need that right now. We just need to find the standard error. So let's go ahead and do that. I'm gonna go ahead and replace this with what I have on my key here. So this is going to get replaced with this. So that's our standard deviation squared. I guess they're putting the Target one over here. This is the Walmart one over here. Order doesn't necessarily matter because it's addition, so it's commutative. But this is what we're looking for. And then we're going to get these values here from that. So there's the difference, and then this would be equals. All right, so this is the right side here. This is the left side. So then once we do that, now we're going to get our confidence interval, lowest to highest value. Okay. There's that value there. That's what we're looking at. Okay. So that's when we make our conclusion here, this is what we say about these confidence intervals. There is 99% confident that the interval from negative 1380 to 8,564 grams captures the true difference in the mean capacity for plastic bags from Target and from Walmart. So this is a pretty big interval. It's a wide range here because it's 99% confident it is going to be wide. Okay. So now we're at the last part, and it says, does your interval provide convincing evidence that there is a difference in the mean capacity among the two stores? Well, if there is no difference, that means we're talking about 0, right? And is 0 inside of this interval? Yes, it actually is. So that's what we're going to say. Since the interval includes 0, here's the interval, it is plausible that there's no difference in the two means. Thus, we do not have convincing evidence that there's a difference in mean capacity. However, if we increase the sample size, we only took 5. It's not very reliable, but if we increase that sample size, we probably would be able to find a difference, since it seems pretty clear that Target bags have a bigger capacity. Yeah, look at that. So that larger critical value that we got, at 4.6 right here, that's what's causing this to happen, that multiplier. It's making that interval so wide with that sample size. So if we increase our sample size, that would change it. All right, very good. Moving on to the next idea, which is running significance tests. So this is where we're getting the null hypotheses and all that. So in general, this is going to be when you're finding the difference between two sample means, you're writing up your null hypothesis. What is that hypothesized value? Okay, so that's what we want to know. Typically, it's going to be 0 to show that there's no difference, or we can show that they are equal. Okay, if you want to show no difference. So that's what we're looking for here. Let's go ahead and look at an example. Both of these, by the way, will be on Kitup. So, and you're still going to need your calculator because we got some data that needs to be put in. So the hypothesis test for the difference between means. So the stronger picker-upper is what it's called. So maybe you've seen Bounty commercials. The manufacturer claims that they are the quicker picker-upper, but they also, are they also stronger the stronger picker-upper. Two AP Stat students, Wesley and Maverick, decided to find out. They selected a random sample of 30 Bounty paper towels and a random sample of 30 generic paper towels and measured their strength when wet. To do this, they uniformly soaked each towel with 4 ounces of water and measured their strength when wet. To do this, they uniformly soaked each paper towel with 4 ounces of water, held the 2 opposite edges of the paper towel, and counted how many quarters each paper towel could hold until ripping alternate browns. Here's the results. Okay, so we have 30 each here, right? Okay, so it says display these distributions using parallel box plots and briefly compare these distributions. Based only on the box plots, discuss whether or not you think the mean for the bounty is significantly higher than the mean for generic. So what I want you to do, like they already do it for us, but obviously this problem would require you to create this, okay? So let's recap real quick how you would want to go about creating this on your Inspire. So I'm gonna go ahead and make a new document, list in spreadsheets. Let's call this one bounty. Let's call this one generic, keep them straight. And we're gonna go ahead and type in all this data. So I'm gonna skip ahead. I would like you to pause it or whatever's the best for you. I'm gonna make this larger and you guys can type in that data real quick. And we're just gonna go through the process of how you would make these box plots near each other. But I'm gonna go ahead and skip ahead to where I've typed all the data in. You need to be typing yours in. All right, so I've got all of mine typed in. Each list holds 30. That's going to be a good thing if you're already thinking right now, like I am. To show normality, we have to have at least 30, so we're going to meet that requirement. But let's talk about once you've got your data typed in. Again, if you need to pause and type it in, do that. But we can create a distribution or a graph by hitting Control-Doc to get an extra page, data and statistics, and we're going to go ahead and start with the one we want. We'll start with bounty. And then we're going to press menu and change it to a box plot. So this is going to look like the one that they have here, but we also want to get the other one on here, okay? So let's go ahead and add a new page. So this is how we do that, or we're gonna modify our page. We're gonna press Control. We're going to press menu. One second, I gotta remember it. I'm trying to remind myself how I did this. Right, okay, so this is how we do it. Press document, page layout, and then we can select the layout we want, and we want the top and bottom here, number 3, to make it like this, okay? So now we're gonna press menu, data and stats, and now we wanna put the generic here. And then we're going to change that, pressing menu plot type, box plot on the bottom. Now to go between these, we have to click using that touchpad. Also, we want these to be on about the same scale. So the max here is 128. So let's make the max 130. The max here is 103. So 130 is going to be our upper boundary. Let's do the minimum here is 77. So let's make the minimum like 70. So 130 is the max, 70 is the minimum. All we need to do to change these to make sure they're on the same scale is press menu, window settings. So let's make this one 70 and this one exactly 130. So we put OK there, changes the scale. We're changing this one as well. Click down here, press menu, window zoom, window settings. We want 70 and 130. All right, so roughly what we've done is we've duplicated what they have here on, they've already done for you. So I just wanted to share a way and refresh our minds on how we would make these charts. Of course, as we hover over these, we can see all the statistics. And I would say just by the eye, significant. I can tell you that the p-value is going to be very low on this one, so we're probably going to reject our null hypothesis. Anyway, it says both distributions are roughly symmetric, but the generic brand has 2 high outliers. It says based only on box plots, discuss whether you think the mean for bounty is significantly higher. Yeah, I mean it's just almost certain that the mean is higher here. All the values, pretty much every value, the highest value here is equal to the lowest value here. There's no doubt that the means are going to be higher. Right? Centers are so far apart and there's no overlap in the distributions. The bounty mean is almost certain to be significantly higher than generic mean. If the means really were the same, it would be virtually impossible to get so little overlap. I think this is a very obvious question here, and that's how you'd want to respond to it, just by looking at the graph. Now it wants us to use a significance test to determine, we want to determine if that wet Bounty paper towels, oh no, wet Bounty paper towels can hold more weight on average than the wet. So if they can't hold more weight, be the null hypothesis, right? That means the difference between them would be 0. Obviously by the graph, that is not what it looks like at all. And then what we're trying to show is that Bounty, that difference between them, if I subtract these, if I subtract them, I'm going to get a positive amount, which implies that Bounty is actually able to hold more. And we're doing this at the 5% significance level. It didn't tell us any kind of significance level. Get rid of that. But that's what we're going to be doing. So stating our hypotheses is the first part of this. And we know that mu of B is the Bounty. Okay. And we have mu of G, which is the generic. So we have to check these same conditions. First off, it says a random sample. Did we use a random sample? Yes, random sample, random sample. Perfect, that's met. Normal, even though there's 2 outliers, both were reasonably symmetric and the shapes are at least 30. So as soon as you have that, N is at least 30, so it's safe to use these procedures. Now this will be T again, okay? It will be T again because we don't know sigma, so we're going to be using this T chart here again. Right. Let's go back to it. It is reasonable to assume that it's less than 10% of the population. Of course, there's millions of sheets of paper towels that are produced. Okay, it's time to run the test. So for us to do this, for us to run our test, we have to calculate the test statistic. Okay, and here is our formula. We go back on our formula sheet to get that test statistic for your your significance test. It's statistic minus parameter, standard error of the statistic. So the parameter here should be 0 because we're trying to show that it's different, right? But we also are going to need the means and standard deviations to be able to do this. Here is the formula for this. We're using these formulas again. X1 minus X2. We're using those to help us with this, but we need to find the means and the standard deviation. So we're going to have to go back to our calculator in a second, but I'm going to go ahead and write this up. So look at what I've written here. We're trying to find the mean and standard deviation for both samples, and we just learned the cool trick to do that. So let's go back to our data over here. We can run all of this in one step. Menu 411. You just want to make sure that it's 2 lists. Okay, so we change that to 2, and we know that we want Bounty versus generic. So Bounty is going to be, it shows right here which one is which, by the way, if you're highlighting over there. So we get this for Bounty as the mean, and you can see, look how different these means are. This is almost for certain going to be significant. I just know it. The standard deviations are pretty similar though. Look at that. And then the medians are about equal to the means, pretty close. So we know it's symmetric. So let's go ahead and write down those. There they are, in there. All those statistics we want. And now it's time to set up the test statistic. So we have to do, we're using this formula, statistics. So that's when we subtract the 2 means that we just got. So it will be this, subtract this right here. Then we have the parameter, which is the null hypothesis. So what was our null hypothesis? That would be 0, right? So this is going to be that parameter. So that's what's on top. And then on the bottom, we need the standard error of the statistic, which is going to be the formula here. So we're using all that. And what we get when we do that is going to be this setup here. So let's put that inside of here. Here's our test statistic right there. Okay. So we just need to find that value, which is, when we calculate that, it's 17.64. If you want to try that, type that in. Let's just make sure we know how to type that in. If I hit this, I can type this. I'm going to make a fraction, control divide, make a fraction. I'll put in parentheses 117.6 to take away 88.1 minus 0. On the bottom, I'm going to start with a square root. Then I'm going to make two fractions essentially for this, just to go ahead and have it there. 0.64, we'll square that. 30. 3, square that. 30. So that's the quick way of doing it. Now, if you make a mistake here, so there's that value. That's a little off from what I have here. It's not too far off. I will actually change this to 0.5. I don't think I made a mistake here. This. Good. Yeah, that matches. Okay. Not really sure about that. If you made a mistake though, you could just easily copy and go back and edit whatever you want. Okay. So we're going to use 17.65. Now we need to use, now that we have the test statistic, it's time to use this t distribution table. And remember, this always shows values to the right. And we're also interested, we have to keep in mind what kind of tail test we're doing. Is it a right tail, a left tail, or a two tail, which is important. Okay, we have our test statistics. So the table shows this. Okay, that's what the table shows, this first one. If we use this, we have to subtract the value from 1. If we have this, we can just find this value and double it. So that's essentially what we're going to be doing. So let's find our value on here. We have our test statistic, which is 17.65. Good grief. What is our degrees of freedom? Because we also have to have that. That's on the side over here, on this column here. So we need degrees of freedom. Degrees of freedom. Okay. So we know that our sample sizes are 30, but we're going to take away 1, so that's 29. Okay. So when we're finding this p-value, so that's what we want. We want to find the p-value. What is this p-value going to be? Because we're using, oh, and also we need to know what kind of test. So this is greater than. So back in our notes, we're thinking that this greater than is to the right. So whatever probability we get from this table, probability is at the top, right here. Whatever probability we get, we're using it. Okay, that is the probability we want. Just that. We don't have to double it or anything. So our degrees of freedom is 29. And we don't have a confidence level. That's not what we're talking about here. We're just looking for the critical value of, we're looking for this value on the table, and I'm pretty sure we're not going to find it. It's just too large. Yeah, it's not on here. So it's beyond this value, and you can imagine it's pretty good distance from it. This is extremely significant, basically, is what this is saying. This is way too unlikely to happen by chance. And since it's way over here, way off of this table, beyond this 0.0005, we can imagine it's almost 0% chance of happening. It's almost zero. So that's what we're actually going to put in here for this. That's what we're going to put. So so we're using that degrees of freedom. The p-value is approximately 0 because it's just far off of that table. Okay, it's approximately 0. That's the probability. What does that mean? Well, since the p-value is less than 0.05, if the p-value is low, remember, reject the HO. P-value is less than 0.05, we reject HO. There's very convincing evidence that the wet bounty paper towels can hold more weight on average than the generic. That all depends on this test statistic. So the hypothesis testing that we've been doing for since chapter 9, and that's what this is based on. So hopefully this makes sense. That concludes like comparing two distributions for means and proportions. So I'll go ahead and stop the video here. There's going to be a few more lessons we got to get in, but we'll get it knocked out.